Hello guys, today we'll look at question number 528 on Leetcode, random pick with weight. So you are given an array W of positive integers where Wi describes the weight of index I, and we need to write a function pickIndex which randomly picks an index in proportion to its weight. So for example, if W is equals to 256, then if I called my pick index function 13 times, then my function should output 0 on an average 2 times, 1 on an average 5 times, and 2 on an average 6 times. Why? Because I have 0th index weight as 2, I have first index weight as 5, and I have second index weight as 6. So anytime we pick an index from array W, we need to adhere to the conditions of the weight. How can we achieve this? So let us say we have a function foo, right, which gives us number between 1 to 13, and this spits out the number 1 to 13 with equal probability. So if I call function foo, it gives me 1 with probability of 1 by 13. It gives me 2 by probability of 1 by 13. It gives me 3 by probability of 1 by 13, and so on. And what is this magical number 13? So magical number 13 is here the sum of all the weights here. Okay. So if we have this function foo which spits out number from 1 to 13 range with equal probability, then what we can do is we can call this function foo inside pick index, right? And whatever number it gives, so it gives say 7. So what we'll do is we'll bucketize our numbers according to the weight. So here I have weight of 2, here I have weight of 5, and here I have weight of 6, right? So whatever foo gives the number, whichever bucket it falls into, I can simply spit out that index, either 0th index, either 1th index, or the second index. So if foo spits out 7, then I'll output 1, and because the probabilities are equal from 1 to 13, the probability of foo getting number from 3 to 7 is 5 by 13. Probability from 8 to 13 is 6 by 13, and probability of splitting 1 or 2 is 2 by 13. So the weights here are now distributed according to what we had. The probabilities here are distributed according to what we had in a W. Now that we understand how can we make use of this function foo, we need to implement this function. And this function, which gives us number from 1 to m with equal probabilities of 1 by m, such function is called a random number generator, right? This is a function which generates a random number between a given range with equal probabilities. Now, each language has its own random number generator built in. So Python will have a random number library. C or C++ will have a random number library. Once you start using this built-in random function, the next question interviewer will definitely ask you is how would you implement a random number generator? First, we need to get some mathematics brushed up, and we need to recall that in order to generate something from 1 to m, what we can do is we can take a random number h and do mod m. This function f of h will always give me a number between range 1 to m because I am modding by m. Mod means remainder h divided by m and the remainder, right? So it will always give me between 0 to m minus 1. We can use this as a random number generator. We can supply a seed here and we do this mod m and get our numbers in the range. But we also need them with the equal probability 1 by m. So there is a property where suppose if h and m have any cofactors, then if I do this on all axes, say 1 to some n numbers, then because of the cofactors, my buckets formed would be cube. It will not be with equal probability 1 by m. It will not be with 1 by m. So some buckets will have more weight and other buckets will have less weight. So in order to avoid this cofactors, what we can do is we can make our m to be a prime number, right? And once we do that, x cannot have any cofactors with m because m is a prime number other than the m itself. right? And in order to randomize x, what we'll further do is we'll define a function f x to be a into x plus b mod m. So I'll write this on a new page. F of x equals to ax plus b mod m, right? Where m is it? So here a is a constant and b is a constant. What is x here, right? We don't have any x in the input. So in order to generate this random numbers, what we'll do is we'll input x first time any random seed of our choice. It can be any number 1, 2, 4, 7, 8, 3, 3, 2, 0, 3, any number. And what we'll do is to generate the second number. So this is generating first number, this is generating second number. X1 will become the random number outputted from x0. And to generate the third random number, what we'll do is we'll use the second random number here as the seed. Okay. And why are we doing ax plus b? This is to provide more randomness to span all the numbers from 0 to m minus 1. Okay, so remember this, guys, that whenever we need to implement a hash function in an interview, you need to use this particular equation to generate the random numbers or the hash function, where a is any constant, b is any constant, and you put x as a seed and you do mod by a prime number. So now let us see this in code, how we implement and test our theories. Okay, so we have the constructor w. I'll take this w into a variable self.w, right? And I'll declare also the total because we need to use this total to declare our random function. Now I'll declare a with some constant, right? I'll declare b with any constant. So what is our constant? It can be anything. I just type anything here. This can be anything, should be a number, right? And I'll declare m to be a prime number. What prime number? So a commonly used prime number, a very big prime number which satisfy that it's a very big prime number, which means it has a lot of buckets, is 10 raised to 9 plus 7. Okay, this is a very good prime number to use for modulus because it has like 10 raised to 9 plus 7 buckets. Our hash function foo will be equal to self.a into some random seed. Okay, now we also need to declare a seed. Now this seed can also be a random number, anything you want. Okay, plus self.b, and this whole thing should be modulo by self.m. And we need to select this random integer in our pick index function. Okay, so when we call a pick index, right? So what we'll do is we'll generate a random integer, and this will be in range of 0 to m, which is a very big number, 10 raised to 9 plus 7. But we need this number to actually be from 0 to total of w. So how do we map this random number from m and bring it in the range from 0 to total of w? So we'll just do simple math. To bring it, the equation should be rand by total of w, which is actually self dot total, should be equals to rand divided by self dot m, right? So in order to map from m to total, this should be our equation. So we'll take the divider and we multiply it and bring it on the next side of equality. This becomes our equation. So our new random, now this random number is mapped from 0 to the total of the weight. Now we have range of rand from 0 to say 13 in our example, but we want to map this 0 to 13 to the index. So what we need to do is we need a running sum which says something like this. So we have 2, 7 and 13. So this is a bucket 2. So if our random number falls between 0 to 2, we'll assign it 0, and this is 2 plus 5. We'll assign it 1, and here we'll assign it 2. So 2 plus 5 plus 6. So if a random number falls between 1 and 2, we'll output 0. If a random number falls between 2 to 7, we'll assign it 1. And if a random number falls between 8 and 13, we'll assign it 2. So we need to find out where our random number is falling. So what we'll do is we'll also construct this running total count as an array in a constructor. Okay, so self.running contains our running total, right? And since we need to find out where our random number is lying in a running array, basically this is a sorted array. What we can do is we can just do a binary search for where random falls in self.running. And in order to do this, we can use in Python an inbuilt functionality called bisect. So bisect has a function called bisect left, which gives us the index to insert a particular integer in a sorted array, which means it also finds where a random number lies in the running total count. Okay, and this is the index, and we just need to return this index. So let us try to run this code. Let us try to submit this code. This is a wrong answer because we haven't updated the seed. First random number generated by this seed, and we need to update our seed. We'll update the seed to be our current random number, right? And which can be used for generating the second random number, and so on and so forth. Let us try to submit this code. Oh yes, success. And you can actually change the constants to see if your hash function is actually correct. So you can change it to anything other than this. Keep the prime number as it is. Change the seed as well, and again submit the code. So it still accepts. So this random number generator, a into x plus b mod prime number, is a very good functionality you should remember for any interview. I hope you liked the video. This was a lengthy video. I apologize for that, but I needed to cover how to generate random numbers on your own without using the inbuilt functionalities provided by languages. Interviewers will definitely ask you if you use the inbuilt functionality, they will hop on to a follow-up question that how will you generate random numbers. Please like, comment, and share the videos. Subscribe to my channels for more videos like this. Thank you so much.